All right, let's look at an example for perpendicular and parallel axis theorems. All right, so let's look at the example we've looked at before. All right, so you have a rectangular region and the density is rho is equal to xy. All right, and we found the center of mass to be 2 comma 4 over 3, 4/3. All right, we want to find the moment of inertia about the x-axis, y-axis, z-axis, and about the center of mass. All right, so let's do that. All right, first, here, moment of inertia about the x-axis. So what we do is just double integral over this region, and the distance would be just the y coordinate, so y squared. With the mass element. So in this case, it's just a rectangular region. So you can see that it's going to go from 0 to 3. So x goes from 0 to 3. Y goes from 0 to 2. So we're going to do dx first. dx, dy. And density is xy. So xy. But we have to multiply by y squared, so you end up getting that. All right, and I'm going to cheat a little bit. So this comes out to be, so do the computation, which is not that bad. It's just a little tedious. It comes out to be 18. All right, and how about a moment of inertia about y? So we do the integral over this region, double integral over this region. And the distance is determined by x coordinates, so x coordinate squared, then mass element, right? So we can set it up exactly the same way. X goes from 0 to 3, y goes from 0 to 2, right? So you have a xy dx dy, so that's the mass element, but you have to multiply by x squared, so you have an x cubed there, right? This comes out to be, and I'm gonna cheat a little bit here, it comes out to be 81 over 2. Right, so this is just a simple computation there, right? Just using the definition and evaluate the integral, right? For the next two, we would like to use, we want to be a little bit lazier. We would like to use a perpendicular and a parallel axis theorem, right? Perpendicular axis theorem tells you that if you want to find the moment of inertia about the z-axis, you just have to add I sub x and I sub y, which we already found in part A and in part B. So this is going to be 18. 18 is same thing as 36 over 2. Plus 81 over 2, which is going to be 117 over 2. All right, so this was a by perpendicular axis theorem. All right, so this is a good place to apply perpendicular axis theorem. Once you know I sub x and I sub y, I sub z is just the sum of those two. All right, so how about the I sub m? So this is a moment of inertia about the center of mass, right? So remember that we have parallel axis theorem, which tells you that I is equal to I sub m plus total mass times d squared, right? So in this case, the I could be any axis parallel to z. How about the z-axis itself? So we can put z here too, right? Then if you want Im, so you can just solve for Im. So Im is equal to, let's see, so we just need to put that over. So it's I sub z minus md squared, right? So in this case, let's see, the d squared is going to be, we want to find d squared, So that's the distance between here, origin, because the z-axis is there, to the center of mass, right? So d squared is simply 2 squared plus full third squared, which is going to be 4 plus 16 over 9, which is what, 36 plus 16 over 9, so it's 52 over 9. Right? So d squared is 52 over 9, right? And the total mass, I think we already found total mass before. I think it was 9. So let's just say, so total mass, and it was 9. So if you want to find the I sub m, all you have to do is do I sub z. So this is the moment of inertia about the z-axis. Then you have to subtract md squared, right? So I sub z is 117 over 2 minus m. In a previous example, total mass came out to be 9. Then d squared, we just found out that the 52 over 9, right? So this is going to be equal to 117 over 2 minus 52, which is going to be 104 over 2, and that's going to be 13 over 2, right? So that's the moment of inertia about the center of mass. So this is by, so here we use the parallel axis theorem there, right? So if you know I sub x and I sub y, I sub z can be found using the perpendicular axis theorem. And if you want to find a moment of inertia about the center of mass, all you have to do is Iz minus md squared. All right, that's it. I hope that this was clear.